In this video, we will go over the properties of logarithm. We will see how we can use the properties in different ways. To expand the first example, we're gonna use a product of property. Log base 4 of 2x cubed y squared is equal. We know that the product of properties says if you have like log base a of m times n, this is equal to log base a of m plus log of base a of n. Let's use this property for this example. It's equal to log base 4 of 2 plus log of base 4 of x cubed plus log base 4 of y squared. For the next step, we gotta use the power property. The power property says if you have log base a of m raised to the power of p is equal to p log base a of m. Let me put those properties in a box. This is product property, and this is power property. Then this one is equal. Now the first example is log base 4 of 2 plus 3 log base 4 of x. See, I use this property to expand this one, plus 2 log base 4 of y. This is equal log base 4 of 2, it's 1.5 plus 3 log base 4 of x plus 2 log base 4 of y. This is the final result. This is cubed. For the second example B, where I have log base, here is 2, log 2 4th root of x cubed over 3x squared z, I have to rewrite the radical with a rational exponent, which means I have to write it is equal to log 2. I have to get rid of the root. That means I'm going to write it x cubed over 3y squared z raised to the power of 1 over 4. Now I have to use the power property to simplify more this expression. Now I will have here is equal to 1 over 4. Since you know the power property says when you have a log base a of m raised to the power of p is equal to p log base a of m log base 2 of x cubed over 3x squared z. Since I have here a quotient, I have to use a quotient property to simplify this, where it says when you have log base a of m over n, is equal to log base A of m minus log A of n. I'm gonna use it here. It's gonna be 1 over 4 log 2 of x3. I'm gonna write parentheses here, minus log 2 of 3x square z. Now I have to use the product property again, because I have product here in the second term is equal 1 over 4 log 2x cubed minus log base 2 of 3 plus log base 2 of y square plus log base 2 of z. You see here that I have like terms that are raised to the power, which means I have to use the power property to simplify it more. I'm going to have 1 over 4. Here is going to be 3 log base 2 of x minus log 2 base 2 of 3. Here I will have 2 log base 2 of y plus log 2 of z. Since I don't have space at the bottom, I'm gonna continue at the top. I'm gonna simplify by distributing. It's gonna be equal to 1 over 4 3 log base 2 of x minus log, I'm gonna get rid of the inside parentheses, log base 2 of 3 minus 2 log base 2 of y minus log base 2 of z. This is my final result for example B. I'm just gonna write B here. For my third example, I have 2 log base 3 of x plus 4 log 3 of x plus 1. Since the log expression have 3 like the base, the same base is 3, to simplify this equation, first of all, I'm going to use the power property. It's equal to, here, I can write 2 log base 3 of x is what? We can write it as log base 3 of x raised to the power 2, or x squared. Plus, I will do the same thing for the second term. This is, I can write it log base 3 of x plus 1 raised to the power 4. Since we know when we have log base a of m raised to the power p is p log of base a of p of m. I can see here these terms looks like these terms. They have the same shape, which means I'm going to use the product property to simplify more this expression. This is equal to what? I can write it, it's log base 3 of x squared times x plus 1 raised to the 4th power. And this is what product property says. At the end, I'm going to write 2 log 3 of x plus 4 log base 3 of x plus 1 is equal to log 3x squared times x plus 1 raised to the 4th power. This is my final result. And we use those when we have the same base, always.